Hey, folks. How's it going? I hope everyone's doing well. Let's see. Just putting all the pieces together and getting ready. Water. Water's going to be an important one today because I'm sick. So we're gonna be jumping into some jank coding, and I was taking a look at what we have remaining between now and the conj for the big stuff anyway, and we're getting there. We are absolutely getting there in a way that is pleasantly surprising. Yeah. I mean, there's a ton to do still, but we're in a good position to have a strong offering when it comes to the conj. The conj is in 6 weeks, basically. Now, yeah, my development progress is going to slow down on jank in the next 6 weeks because I need to start working on my conj talk. And I'm going to need at least a month of just at least a couple days a week probably preparing. So that'll slow things down a bit. But I think we're still in a good spot. I'm working on the error reporting for C++ errors. I don't have anything to show for that yet, but it's going to be great. I've been doing a lot of stability improvements based on feedback that people have been coming in with, various bugs and whatnot. Been trying to get those fixed for them. Let's see. Let me get the fan. Just want to run through the other things that I have sort of set up here. So I still need to do more docs and examples, and I will. I'm going to have a bunch of examples for command line applications, graphical desktop applications, as well as like basic games. These are going to be part of the website. There's going to be like a showcase. There's going to be some examples with projects you can easily clone, get into it. We're going to have all that done for the conj, for sure. The only, there's nothing stopping us from having that now. It's just the fact that I'm working on other stuff. So that we're not blocked on any features or anything for that. I want to get macOS x86 support into Brew. Again, that's basically just hooking it up into CI. I would really love to have CPP def, CPP fun, and CPP struct done, but I don't know if that's going to happen. One of my mentees is working on this, and I don't know if that's going to be done. But I imagine that in the talk, we're probably just we're gonna talk about what's done right then, but then we're also gonna talk about what's going to be done basically at the time that the video for the talk is going to be released. Based on how it went last time, the conj was last year was in October, and then the video didn't come out until April the next year. And so it doesn't really make sense, and I'm sort of keeping this in mind, it doesn't really make sense to say in the talk this, we don't support this yet, we don't support this yet, if we're actually going to support it by the time the video comes out. And so I need to try to balance what we support at the time of the talk as well as what we're going to support by the time the video comes out. And I'm going to try to make that clear. This is going to be one of those things where I think probably at the conj, not going to support it yet, but certainly within the first couple of months of next year, this should be supported. Aren't they doing some amount of live streaming? Yeah. Hey, Fromophobic. I hope you're doing great, man. So the con's just going to have a free live stream, which is the first time they've done a live stream for free. Very cool. So there is that, but then it also generally takes like at least a couple of months, if not a few months, in order to get all the videos onto YouTube. Yeah, they did live streaming last year, but it was paid. Exactly. So now it's going to be free, and I think that's great. I think it's a great move. Might as well let people in, let them enjoy the talk. We want Clojure to grow, after all, right? So makes sense to bring in as many people as we can. And then, if you want to go to the conference and have the whole conference experience, meeting all the people and everything like that, then you got to pay for that. So I like that. But yeah, I'm going to try to balance the sort of what is available at the con as well as like what's going to be available going forward. Howling AF, welcome to the stream. Hope you're doing great. I've reworked the website about halfway. If we take a look at jank website, I need to figure out a better showcase sort of example that shows off C++ interop within Clojure, as well as static typing combined with Clojure's dynamic typing. This works. It's just boring. Yo, how's it going? Well, I'm sick today, so that sucks. But otherwise doing well. I hope you're doing well as well, Howling. So I want to come up with a better example for this. And then here, I want to replace this. I have some I am GUI shit here. I want to replace this with like a tile or like a grid of showcase tiles of a bunch of like small applications. And then this would overlap with the examples that I was talking about that we're going to have as part of the documentation as well. But each of those examples is going to have like a screenshot of what the end product looks like. And that screenshot is going to be, is going to show up in the tile for the showcase. So I think that will replace this area. So I kind of know what I need to do there, but I just need to get those examples together and everything. Then there's some build system work that needs to be done. The sandboxing on macOS is the biggest thing because we just don't have that right now. On Linux, whenever you're using the native build system for jank, it automatically runs inside of a sandbox, which is super cool because it means that like the arbitrary stuff that you're executing doesn't actually have access to your whole computer. For example, if it wanted to read something from your home directory, it wouldn't be able to. So that's a big win, but we don't have that on macOS yet. And there is software that's going to allow us to do that. We just need to set it up. There's some more like mainly work around static linking that I want to support for that. Let's see, some AOT stuff we need to do. Maybe we'll look into some of that today, depending on where we get. I'm gonna be honest, I might like after a couple hours just sort of crash in terms of energy. So we'll see. But this is the second thing I have slated. And then array support we talked about before. DJ Blue's actually picking at least half of this up. And he has a pull request up that implements the whole array object. I don't know if he's going to do the native array support. I may need to jump in for that. And then really the only other thing that I think is essential to get for the conj is the embedding of jank, making like improving the story there, making that a saner thing to do. And I have some side work going on to make this happen. So this will be done. This will be done by the time we get to the conj. And I'm hoping I can show some of that off at the conj as well. So altogether, I like where we're at. And that's the high level, in case you're interested, of what I'm going to be working on in the next 6 weeks. After conj, we'll be wrapping these guys up, and then probably jumping into like the object side of things. So def protocol and def record. Why is def record not here? Oh, it is. It's down here. I don't think we're going to do def struct, because I think def struct is basically replaced by def record. We'll see. I'll put it down here. Not all these make sense. Like gen class doesn't make sense for jank. And I don't even know if like this shit's gonna make sense either. We're gonna have to see, because C++ is not like, you know, C++ native shit is not the same as the JVM Java shit that Clojure normally runs on. So we'll see. We'll see what we can do. But this is what's been going on. And then let's see. Before we jump into the coding task for today, was there anything what's been done recently? Jank. Is there anything I want to talk about that's been merged in recently? Oh, yeah. So we have a brand new REPL, terminal REPL client. And so first off, you'll notice that this is colored green. And that we also have syntax highlighting as well as brace completion in here. And that's pretty nice. So we also have syntax highlighting on the printed objects that are returned from whatever expression is there. And then the terminal REPL client that we had before was based on LLVM, and depending on where your LLVM was compiled from, it may not have supported the arrow keys. So if you wanted to go like up into the history or left and right, that may not have been supported. And on my machine, because I've just been unlucky, I guess, it wasn't supported. And so that sucked. It basically meant that the terminal REPL client was not usable. And so yeah, all of that's been replaced. So now not only do the arrow keys work, but also we have syntax highlighting. And then on top of that as well, we have completion. So when I just type foo here, we already get some shadow text hint that says if you just hit tab, you're gonna get foo bar completed for you. So that's nice. But also if you do something like namespace, so let's say we require jank perf. And you do a tab here, Then you're going to get suggestions for just the owned vars that are in there, which is nice. And then also just normally referred vars that you have as well. Like if you wanted to call reduce, then you could just do this and then hit tab, and then you have a few different options. So you're gonna get your options there as well. Hey Prom, welcome to the stream. Hope you're doing great. So that's been the biggest thing that's happened in the past week, was replacing the terminal REPL client. And this was just part of the error reporting work that I was doing. All that's been merged now. And the goal there is just to really improve the UX. And so the terminal REPL client that we had a really bad UX. And now we're much better. We're much better. This one also supports, I forgot to show, this one also supports multi-line editing. So unfortunately, it doesn't hang the indentation, even though it should. And this is a bug in the library that we're using. But, oh well. I already ran into a few other bugs in this library, but it was the best library I could find. But yeah, even if you go in the history, like if you go up from here and then multi-line, that's going to work. And then you can go up and down inside of that. And then, you should be able to go down from here to do. Also, why doesn't one show up here? Yeah, the history is weird. Oh, interesting. So just 1 and 2 don't show up. Yeah, I don't know what's up. Like, I didn't code any of this history stuff because it all just comes from this library. So I wonder if it does something where it doesn't count like. Oh, it probably just doesn't count things that are below a certain length. It does. Yeah, that's odd. Multi-line repo, I keep wanting to use that whenever I use Python as a little calculator. Yeah. Yeah, so for this, if you just hit Control-Enter or Shift-Enter, assuming that your terminal is set up to distinguish those, it may not be, in which case you'll need to configure your terminal to actually send different codes for that. But if you actually have your terminal send the different codes for Control Enter and Shift Enter, then Jank REPL will pick them up. I'm gonna make a note about the minimum length going into the history because I don't like that, and maybe that's something that's configurable. We'll see. Okay, note added to self. So with all that said, that's what's been going on mostly for the past week. Let's jump into what we're going to be doing today, the first thing anyway. So we have this CPP cast functionality that allows us to do a cast between two different types. And then there's a so it's on the C++ side, it's basically static cast. Well, it's literally static cast. That's what it code generates to. But it also has additional behavior. And that additional behavior is the ability to do trait conversions. And so if you have a native value, like say, for example, you have some, I'll do a different example down here. So let's say bar. So in here, let's say you have some integer I. Now this is a straight up native integer here. There's no allocation, dynamic allocation that's done. If you wanted to box that, then there are some things you could do, but one thing you could do is you could just cast this. So you could do like I wonder, maybe we'll go the other way around. So let's say you have some boxed things. So I here is a boxed object ref, which is basically the same as Java's object, but it's in jank terms. And if you want to get a straight up int out of this, then you can do this CPP cast to an int. And so you have some boxed object I. You want to get this unboxed. You want to get this unboxed I. You can use cast for that, and all this works today. And I want to extend the CPP cast behavior today to do one other thing as well, which is if you have so here we have some arbitrary input O. So O is going to be an object ref, and you want to cast this to a typed object instead. So still a boxed jank object, but you actually want to do it cast to a type. And so this is basically like trying to cast from in JVM. It's like trying to cast from object to string or I persistent map or something like that. Then this would allow you to do that. Nice to see you, May. Have an awesome day coding today. Oh, thanks, Braxton. Nice to see you as well. I hope you have an awesome day. I appreciate the kind words. So what we want this to do here is to basically try to cast the object into a persistent array map. And if it is a persistent array map, great. And then we'll get back an object of that type. And if it's not, then an exception should be thrown. So this is basically in Java land. If you had, well, let's just say in closure land, if you had a foo and then you did a let m, and then in closure you could just use cast, and then you did like an I persistent map O. This is basically the same thing here. This is basically what you're doing, but in jank we got to do the full C++ namespace shit. I've been following along, just don't always get to chime in. Oh, that's cool, man. I appreciate you. Thanks for following along, and also thanks for chiming in. Since downloader time hits different, yeah, for sure. Well, thanks for tuning in from down under. On the other side of the world, where everything wants to kill you. Australia is like I remember reading an article about just all the different insects and animals and everything like that are just terrifying. I don't know if it was just the article painting a picture, but it did seem like quite the adventurous place. Yeah, Thursday eating brekkie. Not everything, but there are a few things for sure. Yeah, there's actually a lot of music I listen to comes out of Australia. I would send huntsman pics, but I don't like scaring it. Oh, is that's the spider? I won't search that either. We'll be nice to everybody. Size of a decent sized plate. Damn. Yeah, no thanks. I'm good. But yeah, actually, I do. A lot of artists I listen to come from Australia. I don't know why. Okay, so we want to do this. It's all X. So we want to detect this case during analysis that we're casting from a type erased object into a typed object. And so here we're going from object ref into a persistent array map ref. We want to detect that, and then we want to do code gen for that differently. And the code gen for that is basically just it's gonna check, right? It's gonna say, okay, well, is this type erased object a persistent array map? If so, great, go ahead and do this cast. And if not, then throw an exception. Now, the really cool thing about this is, and hopefully this gets you guys a little pumped up, is this basically lays the groundwork for us to be able to do type hints on thingies, so that you don't need to do this manually, and then you would just be able to, do this. I don't know if we're gonna like come up with a shorthand for you guys to not have to write out the whole type name like this. But we probably won't. But either way, this would allow you to put a type hint on something, and then if and then the jank compiler will automatically code generate the cast here, so that it'll throw if you give it something that isn't exactly that. And this is going to make it easier to then sort of meet parity with Clojure in terms of adding type hints on your stuff to improve your performance. So yeah, first step is just getting this functionality to be able to do this easily from jank. Let's do that. So let's get, I'll keep this around, I'll put it down here. Let's do, so we have this, what happens right now when we run this? So it does run, and we're calling this foo with a map, and it is an array map, and it does have foo1 in there, and we get back 1. But the problem is that we're not actually doing useful code gen for this, so I'll show you. So we have this foo function that takes in this type erased object O. This is our foo function that we defined right here. It takes in O, and then the only thing we do is we try to convert O to a persistent array map, which is M, and then we look inside, we pull foo out of M, right? So what we should be doing right here is converting O into a persistent array map, but we're not. We're doing some other weird conversion. And then we're grabbing the keyword and we're doing a get on that. So this is fine, but this conversion that we're doing for V2 is not right. It's just wrong. Let's take a look at why it's wrong. I don't know if our IR is fine or not. Yeah, so this is wrong. Because we have an into object. Well, I don't know if that's wrong. Could be from object, could be into object, because we're going either way. We're going from object to object. We're just going from type erased object into a typed object. I might want to canonicalize how we handle this in the AST though. Conceptually, I would normally think that if you're going from a type erased object into a typed object, that you would be doing a from object into a typed object. Like your from object is meant to be like a from type erased object. It really doesn't matter, I think. But we get to, but we're in control, right? And that's how I conceptually think about the IR, and so I would prefer that the IR represents things in that way. Let's take a look at the relevant code here. So I think we're on CPP util into object. So we have this function, determine implicit conversion. I don't know if that's what we use though. We'll take a look at our analyze CPP cast function. So what we're using here is CPP cast. And so all of that just goes into this analyze CPP cast. So we analyze our type expression. We analyze our value expression. We check if the value type is equal to the type that we want in the first place. And if it is, then we just return the value expression because there's not actually anything else to do. But if it's not the same, then we check if it's constructible, if it's implicitly convertible, or if it's a pointer to void conversion. Okay, and then we say, is any object... Yeah, so here's where we're ending up. We're ending up in this branch because the type we want, which is a persistent array map ref, is any object. Any object is either a type erased object or a typed object. So that's true. And then the value type is trait convertible is just an object ref. So that'll be true as well. So we'll get into here. So I think what we're going to want to do is probably have a check that happens before this, which is if the type that we want is a typed object ref and the type that we have is an untyped object. Yeah, let's do that. So I think we could do is typed object. Nice. And then I think we can do is untyped object. And then that's that. And then so here we'll just do a from object. This ends up being the same as... Oh, we need to take a look at the CPP conversion AST node. Because I don't know what the members are. So we take form type conversion type. Form type conversion type. Now our conversion type should be type. Yeah. So it actually ends up just being the same as this branch here. Maybe we should just combine these branches. Okay. We're gonna let that guy compile. I think this is gonna be all that we need on the analysis side. And then all we need to do is change our code gen and add tests. Unless I miss something. Okay. So that's that. And so now we had an into object before, and then our type was this persistent array map. That's our conversion type. And so now we have a from object. So that is good. That's what we changed, and that did change, and I'm pleased with that. Fromophobic. Always count on you to jump in, say easy. Sorry for the crinkling. I'm gonna open up another throw lozenge. This stream is brought to you by, but not sponsored by, Ricola. Maximum menthol to numb my sore throat. All right. Okay. So now for CPP cast, all we need to do. Fuck. What is this? Oh, it's called from object. Right. So we have a from object in our IR. We have this from object instruction in our IR, and we want to take a look at the C++ code generation for that. So the code generation for from object actually just does code. It converts it into an into object and does code generation from there. So the fact that I changed this into from a into object into a from object in terms of the code generation doesn't matter at all. But it matches my mental model, and so I'm going to keep that. So for into object, we have a few of these different cases. So let's see what we have here. So if we are converting to void, then there's nothing that we do. We just create a local that is initialized to nil, because void it just becomes nil. If we're going from a untyped object into any other type of object, then we just do this. Okay. I would expect this one to happen, but we don't. We end up doing this. I wonder what the type of V2 actually is here. We can check that. Do the old foo on that. So it is a persistent array map. So maybe we don't actually need to do anything for CodeGen at all, because this just works. Yeah, let's try that. So if I give it something other than a persistent array map, so let's say, for example, I gave it a hash map, then this should just throw. And it does. We need to update this error message. Because this error message looks bad. But it did work right. Maybe there's nothing more we need to do. Let me take a look at this code and understand why. So why don't we get into here? The conversion type is not untyped. And neither is the expected type. Okay. So that's why we don't get into there. And then we don't get into here because this is for integers. And then, so that's why we get into here. Okay. And then, so this is a typed object ref. And we do a from object. So this is where we're getting. And we can actually see that right here. RTTI 42. Yeah. Shit. 66. What's 42? 42 is nothing. Was that the wrong place? 66. Right here. Built-in 66. Yeah. That is what we're getting. I was right. But then I misread the stack trace. Nice. Okay. So actually no code gen change needed. All we had to do was that like one line analysis change, and everything else works. Everything else works. So let me add a test for this. Okay, so how do we want to do this? We want to go from a untyped object. The easiest way to lose type information is to just have a function. So let's just say f is some function. If I can learn how to type, and so we'll have an O here, and I want to do my CPP cast. Let's see how we want to do this. I think I want to delete this, and then I probably just want to do an F here. And then I want to give it a persistent array map like this. Yeah. And so what I'm going to do here is I'm going to say M, and I'll use persistent array map as well here. Persistent array map. O. And then I'm going to grab A out of M, and I'm going to say if A is equal to 1, then go ahead and give me success. So this test needs to return success. And so in this case, it's only going to return success if when we call F with a persistent array map, then we are able to cast that object to a persistent array map, and we're able to then grab out. The problem is this test On main, this test would still pass because what we had was like the cast that we were doing basically didn't do anything. It just gave us back another object ref. I want to make sure that what we get is actually something that is a persistent, or that is the typed object. Let me jump to persistent array map. Maybe I'll just access one of its members and do a what is the value type? Pretty sure the value type is V, native array map. Native array map. So yeah, we could access the underlying native array map. Mm-hmm. Yeah, maybe we do that. Although at this point it might be simpler to just not use an array map and instead do the test with like a integer, and then we can just pull that out. So this will be a small integer ref. Hey, yo. Nathan Bags, welcome. Thanks for the raid. I never know how long these things take for everyone to come in. Nathan Bags, I hope you had a great stream. I hope you're doing well. I appreciate the raid. Everyone from Nathan's stream, welcome. We're working on the jank programming language, which is a native closure dialect written in C++ that has unprecedented C++ interop. And I have cough drops and coughs. Nathan, if I'm always exhausted at the end of my stream. If you need to raid and run, then by all means, brother, do your thing. Hey, Quecco, how's it going? So we were, let's see. The small integer ref. Integer, small number. Small integer, yeah. Oh, but this is a... small integer. I think we have a specialization of this template. Mm-hmm. No, we don't. So this one is for object ref This one is for typed objects. Yeah, we do. But it has an object, and so it didn't manage my search. So this guy just has a data that's an I32 inside. I think we could just grab that. Data I. Let's see if this works. It does. Yeah. So we'll do this. So I is just an int on its own, but we detect here that we need to box I in order to call this function. And so we do, and we end up creating a small integer ref box for it. So when we call this function, O is a small integer ref, but it's a small integer ref that's hiding. It's hiding behind its own type erasure. And so it's actually an object ref. Now, in order to get back its full type information, we can do the CPP cast like so. If the cast fails, it will throw. And if it succeeds, then what we get back is I being a fully typed small integer ref, which then allows us to access its data member, which, as we can see here, is this I32. And so we can then compare that directly with this int. And if they're equal, then we will return success here. And that's the goal. And that's the test. And it works. So yeah, let me run this test suite. And if everything looks good, then that's that. That's that feature. Doesn't feel right to finish a feature in under an hour. Normally it takes us longer. Damn. Look, yeah, it's a little too easy. Also, this finishes in 20 seconds now, this test suite. This used to take 1 minute, 20 seconds. And the only difference is now I disable the creation of debug information in Clang. So I did some profiling of what was taking all the time for that. And we were spending over 75% of the time just creating debug information in Clang for all of the JIT compiled code. And for the test suite, we don't actually need that. So I disabled it. But it does raise some concerns for how slow Clang is at generating debug information. Because in other cases, like, I don't know, your application or whatever, you're probably going to want that debug info for most of your operations in case something goes wrong. You're going to want a good stack trace. And it's apparently quite costly to create when you're JIT compiling. So that's not going to be fixed without a Clang change. I haven't looked into doing that yet, but at least now I know that that is a bottleneck to keep an eye on. And it was easy to just disable for this, so we're able to do this in 20 seconds now, which is much better, especially on stream, because that's an extra 60 seconds where I'm just like, yeah, so I guess I'll drink some water and okay. So since that was so very easy, actually, let me open that back up. Since that was so very easy, what would it take to do this? So we'll have, I think that we already support the type hint for this. Let me try. What do I want? I just want jank run. Okay, so we compile. Did I? Yeah. we compile, but we just don't use this metadata right now for the parameter. But it could be anything. I'm pretty sure. Like I could just say bean here. And that's still going to work. So yeah, we would need to do analysis to ensure that the type hint actually has a correct type. Correct meaning like valid type, that it's actually a type that we can resolve. Tempting to look into this right now. Because that would be a pretty slick win. So this would be an analyze fun. There is analyze fun arity, I believe. Somewhere. There it is. And so we have our list for the arity. Then we have our params vector. Then we have our params, and then we loop through our params. We check that it's a symbol. So yeah, what happens with the metadatums of that symbol? What are we doing when we add that? So if we do a jank REPL and we do like a meta of foo on a it's gonna be different because it's gonna be on a quoted symbol. I don't think that's gonna work the same. Yeah, it's not gonna be the same. How do we actually get the meta that we have on a symbol that is added? I'll just put it on something other than a symbol. Okay, so we're just not putting it in, apparently. Probably hint, parse meta hint. So we do a with meta. We parse the metadata and then we do a with meta. So that seems like that should work. It seems like let me see. Symbol. So here's the problem. So for the symbol, when the meta hint is a symbol, the meta object that we create is just an empty map. So we would need to have some other thing that we put in here. So what Clojure does is it puts in a keyword called tag. And I don't know if it makes sense for jank to follow that. Especially since for a lot of Clojure code, if you have macros and such that are putting on the tag keyword, they're basically all going to be JVM types, right? And so if we're going to expect that to be valid type, then that's actually going to decrease compatibility. This is actually going to make jank less portable if we try to use the same keyword that Clojure uses, because literally none of the types are going to be the same across Clojure, JVM, and jank. So we should probably just use a different type or a different keyword. And so I'm thinking, with thoughts, I'm thinking that we'll probably just do some of the types are portable, right? Well, no, see, because we're not doing unboxed types here. I don't think that jank is going to support type hinting things as unboxed types, because that's a sham anyway. The whole point is like you use type hints when you have a type erasure. That's why you need a type hint in the first place. If you have an unboxed type, then in jank that can only happen if you have like full static typing for that type. If we wanted to do it with to challenge, to challenge myself, my own statements on this. If we wanted to do it with unboxed types like long and int and char and bool and whatnot, then we could basically code gen a conversion trait conversion in. So that will still throw if what you've given it is not convertible to that unboxed type. Wow. Got my eyes closed thinking about code. And then I bumped into the microphone and jumped myself. I was lost there, picturing code. Yeah, I think we could do that. I think we could still do that. It's not what we were just implementing. It's extra, but it still does seem like it would be viable. But my point still stands. So in that case, you're right that some underlying types would overlap, some of the unboxed types, but the vast majority of the types that Clojure JVM type hints are going to have are not, and so I still think it would do more harm than good to use the same keyword here. So let's do let's just call this type for now. I've used tag types for macro DSLs. I'm not sure if others have. So we'll do type, and then where's our symbol? Our symbol is typed val. Use the tag types from macro DSLs. Not sure if others have. What are you saying? Is that a reason that one should use the tag keyword? Ah, now we're actually starting to use this. So yeah, the problem is if I do a jank runtime, persistent array map ref, Mm-hmm. Mm-hmm. We need to analyze that as a type. And right now we're trying to analyze it as a value. Mm-hmm. Okay. So let's find out where we're doing that. Hint. Do we search hint here? No. This is probably just happening with eval meta. Eval meta. Just trying to brainstorm pros and cons. Yeah, I mean, I think that the only pro for using tag is that people will already know it, and some bits that are like maybe a macro DSL or something like that that's flexible enough to be able to specify different types could then be still used with jank. But like right now, there's, I think, a fair amount of code that jank would be able to run that has type hints, and jank just ignores those. And then as soon as we start analyzing those type hints, all that code's going to break. And then that's doubly true for any place where tag is being added. Yeah. I don't know. I don't know. I'm on the fence. But we can just go with one for now, and then that's a very easy change if we want to change that. So if I were to I wonder how because meta is evaluated. Where am I evaluating meta for things? Like I should be in analyze map for this. Where were we? Here. This failing. Analyzing code with incorrect tags wouldn't break, right? I thought incorrect type hints were okay. Ah, see, well. So. This is an area where jank cannot possibly do what Clojure JVM does, because we don't have a virtual machine that has runtime reflection, right? And so in Clojure JVM, if a type hint is wrong, phonomophobic, what happens? Like let's clarify what we mean by wrong. So let's say we'll do let's say that this is a string and we create an object, which is definitely not a string, right? What happens? Nothing, right? So this is wrong in the sense that the object is not actually a string. And if we take the type of it, it is just straight up an object. So this is wrong in the sense that the type is a valid type, but it doesn't actually represent the type of the underlying object. Okay? This is the sort of thing that jank just cannot do. Like this cannot work in jank reasonably. If you specify the type of something, then what you're going to be saying is, this is the type of the thing that I have. And that is why we're going to code gen a CPP cast that's going to throw if you're wrong. The whole idea of a type hint where you like this never sat well with me in Clojure JVM in the first place. Whole idea that you'd specify the type of something and then that type would just be wrong, doesn't actually represent the object that you have, and then that just like flies. That's crazy. Is this because I put the type hint in the wrong spot? Let me see. No, still works. Yeah. So this will not work. Now, then there's the other case of like string noodle. That's lying to the type. That's lying the type to the interpreter compiler. Yeah. JW, exactly that. It's just fucking is not good. Jank's not going to do that. So when you say this is a string, then we're going to insert some code that's going to assert that shit's a string. Because here's the reason why. Because in C++, if we try to cast that thing to a string and it's not a string, then that's undefined behavior. And then the entire rest of your program is out the window. Maybe it'll crash, maybe it won't. Maybe it'll run super fast, maybe it won't, you know? Like it's wrong. It's too far wrong that we can't do anything about it to recover from then on. That's undefined behavior in C++. So then we have this second case where we're giving a type here and this is not even a valid, I mean, there's no way the JVM, there's no way the JVM has a type called string noodle. And even less likely that it has a type called string noodle J. Because who spells J like that anyway? Yet this isn't a problem. I think it has to work like that because classes can exist at compile time, not runtime. Yeah, that's not the way that C++'s compilation model works. And so it's not the way that Jank's compilation model works. Because even though Jank has just-in-time compilation, you still need a type to exist before you can reference it. Now we have this other case here where we're specifying a type and that type doesn't resolve. Yeah, I guess we're not gonna have a meta for just an object because it needs to be something that can have metadata. Mm-hmm. Yeah. So, hey, DJ Blue. I hope you're doing well, man. The look, guys and gals, we just need to realize, like, we need to come to terms here with the fact that that type hints in jank are just going to be drastically different from the way that they are for Clojure JVM. Because the JVM just has like all of this other shit going on, like runtime reflection and runtime class loading and everything like that, that allows this to work. But I think in jank and in C++, it just doesn't make sense. And if you could find some mental gymnastics that allow you to make it make sense, then I still don't like it. And so I'm not going to do it. So instead, type hints are actually going to describe the type of the thing, right? And that allows you to say, okay, look, I have this type erased thing, right? I have this function parameter, like this motherfucker. I have this function parameter m, okay? And then rather than m being some type erased object ref, you are specifically saying, I know the type of this is going to be a persistent array map. I know that. Then in that case, what we can do is we can insert the cast that will check, and then JW. So what jank will do in this case is if m is not a persistent array map, is going to throw. What Clojure does, as we were just looking at here, is it doesn't even throw. Like, it's just like, oh, okay, yeah, sure. You said this was a string. It's not. But at runtime it does. At runtime what does? Because in Clojure, like in this terminal REPL client, like this is runtime. This is compile time and runtime. I mean, this is like we've already compiled and evaluated this code by typing it into this REPL client. So we have demonstrated runtime and compile time. For jank, we're going to throw at runtime if the type doesn't match. But I think that we also need to fail at compile time if the type that you specify isn't even a valid type, right? And so if you say like, okay, well, this is definitely a pancake, and if pancake doesn't actually resolve to a known type, then I guess we have two choices, right? We can either fail at compile time and say like, well, pancake isn't a type that makes sense to me. And so you're asserting to me that M is of this type pancake, and I don't know what that is. Then in that case, then we can fail. Or we have the option of ignoring it and just not adding any type hint on. Personally, I don't like the second option. I think if you're going to add a type hint, it should fucking do something, right? It shouldn't silently fail, because this is silently failing. Same thing here. If you put a type hint on this saying it's a string and is not a string, then we're silently failing. My assumption is that types don't exist at runtime. Yeah, that assumption is incorrect. Types absolutely do exist at runtime. You might have maple, please. Maple syrup. When I was in school, I had classmates that would bring in their own maple syrup that they tapped. Where I grew up, it was a common thing to do. I think a type hint may only be used when resolving method calls, otherwise may be ignored. That's not entirely true, DJ Blue. So Clojure handles this specially. If you type hint a function parameter to have an unboxed type like long, then you actually end up generating a custom interface for that type that accepts unboxed parameters. Oh, you meant for the let? Yeah. Okay. Yeah. So for me, this will help for resolving member functions, member variables as well. But it's also like the big win for this is probably for inlining. As you're familiar with, DJ Blue, like if you can put a hint on something, so that way we'll cast it and we'll have the fully typed version of that, then we can do overload resolution better for inline function calls. And then that's going to give you a lot more perf as a result of that. So like type hints should be really fucking calculated moves that need to be correct, because you're introducing a static type. Is this only for AOT? No. When aren't we going through vars? When we inline. So any var that has inline metadata is replaced whenever it's called with the inline version instead. So here, even when you're JIT compiling, if you have a call to nil ? Because we have inlining, it is replaced with straight up a call to this C++ function is nil instead. So this inlining, and Clojure JVM does the exact same thing, and it works in the exact same way. Clojure, like this inlining, is basically like macro expansion, but it happens for var calls that are called directly, and it replaces the var call with some direct interop instead. It is this inlining that allows us to get all of the overload resolution that we get for things like arithmetic. So that way, if you're adding unboxed values, right? If we always went through the var, then you could never work with unboxed values on any of the Clojure core functions. Because in order to call through a var, you'd have to box all the arguments. But that's not the case because of this inlining. Does that make sense? Am I making sense? You were thinking about user code? Yes. So, I mean, anyone can add inline metadata to their own vars, right? But I wasn't thinking about that. I was thinking about Clojure Core because most user code, right? Most applications or libraries in Clojure are just taking data and transforming that data using Clojure Core functions. And so if you have some function, let's take a look at an example. So we have like the ray tracer, right? So here's a ray tracer. Rays are these persistent array maps like this. Okay, so RGB. If I were to add a type hint so when you want to scale to, or not, this is rays are also vec3s. We use vec3s for a lot of stuff in the ray tracer, but and then we use RGB. It could be XYZ. It's just a 3-component thing, right? When you want to scale some vec3 by some number, then you just take all the components, you multiply that number, you give yourself a new map. If I were to add a type hint to this guy to say, oh, by the way, this is a persistent array map, then now the lookups inside of this, like for R, G, and B, those lookups don't need to go through like a virtual function call. Those lookups can be devirtualized, and instead we can just call directly into the persistent array map to look up the value. Similarly, if I know that n is always going to be a floating point value, for example, right, or something that's convertible to a float, then I can type in that as float. Now this is not saying that n is a float. It's saying that it's convertible. It's trait convertible to a float. So that way, whenever the function is called, I'm going to pull out a float. Then when I do the when I do the overload resolution for all of these multiplications, I don't have an object ref on this side anymore. I have an object ref on this side because I don't know what's in the persistent array map at R, G, and B, right? But I have a float on this side, and that's fucking great because we know that floats are what's the term I want? Infectious. Whenever you add anything to a float or you multiply anything by a float, you get back another float. So if you add an integer to something, you don't always get back an integer. If you add an integer to a float, you're going to get back a float. But if you add a float to something, you're going to get back a float. And if you multiply something by a float, you're going to get back a float. And so this allows us to do better overload resolution because we're going to know that what we're going to be getting back here is a float. Now, actually, in this case, it's not going to matter because we're just going to immediately put that into another map. But let's take an example like let's take an example like this. Like if I had type hints on V, then we could optimize the lookup of RGB here. If I had a type hint on this, then we could optimize the overload choice that's chosen here, which then allows us to have a clear type for scale, which then optimizes this, which then optimizes this, right? And so like these type hints can have cascading effects. Anyway, tangent. So back to what we're doing here. I don't think type hints make sense for jank unless they're accurate. And by accurate, I mean two things. One, that it's a valid type. And two, that it's actually the type of the fucking value. And so I think we need to cover both of those cases. Good explanation. Thank you. Thanks for diverting, explaining. Oh, you're welcome. Glad that was useful. Thanks for letting me rant about fucking type-ins. Okay, so let's look into where we are. We had this. This was failing. Why? So in analyze map, we have our expressions. We analyze them all, and then we construct a map and we do a get meta. I think I might just need a breakpoint because I don't know where this is happening. So let me put this into here. Yeah. And now could not be resolved. Could not be resolved. 1803. So we are in analyze map on 3416. And we're analyzing the value. Oh, because we're analyzing the meta map. Okay, we gotta look back. Okay, so it is happening during eval. $416. Okay. Right here we eval. Have an awesome coding session, mate. Drink heaps. Well, one needed, hey. Have a good one, Braxton. Thanks for tuning in, man. I appreciate you. You're always welcome. So when we try to evaluate the map, we also evaluate the metadata. And that is where this is failing. I think it just needs to be quoted. I think if we wrap this, in a quote, then it's going to eval fine. So let's just do a quote. Do we have a easy bit of code I can copy for this? Something like this. The symbol closure core quote could not be resolved. This should just be a map with the type keyword and then closure core quote. Oh, because it's not closure core quote. Quote is a special form. Okay. So now we have meta that actually keeps the type info there. And then we just need to use this during analysis in some places. So let's say for functionalities, we're looping through our parameters here. We'll see that it's a symbol. We grab the symbol. We check the namespace. We check if it is one of those. All right. And then otherwise, say the last thing that we do here is, no, because we changed param here. So we want to do this before. We want to say we want to check the meta, and we want to see if the meta has a type, and we want to analyze the type, and we want to see if the type is valid and error if it's not. So let's do that. Yeah, that should all work. I don't need to do that. I should have. It's called sim. So at this point, we know that we have some type meta. Now we just need to grab. We just need to grab that out. We need it to be a keyword. No, we need it to be a symbol. So if type meta get type is not equal object type symbol, then valid. I don't know if we want. Yeah, I don't know if we want like invalid function parameter for this, or if we want, oh, whoops, I didn't want to change that. I wanted to change the thing I was editing, which is this. Or if we just want invalid CPP type. I think we want invalid CPP type. Object type stir and type meta get type. Thanks for the sub, Braxton. I thought you'd already left. I appreciate that new sub. Hey, Johnny. How's it going, man? Oh, good, mate. I'm glad you could stop by, Johnny. I know that it's late for you right now. Let's see. So we specified the object type string there, and then we're not passing this, and then we have this, and then this closes this, and then there's that. 1240. Yeah, that's a little early / late, depending on how you look at it. Coding's more fun than your in real life bill paying. Yeah, coding is more fun than my in real life bill paying as well. Most of the time. Being a paramedic has good days and bad days. Oh, wow. That is... That's an impressive job, Braxton. Thank you for being a paramedic. Code is predictable. Well, I'll tell you what. I'm glad that we have people. I'm glad that we have people like you who choose to be paramedics instead of just coding on Twitch all day. So I appreciate that. Also, I don't even know what starts hype trains, guys. But there's no pressure for subs or gifts or bits or anything like that. I don't do Twitch for money. I do Twitch to give you guys a glimpse into the development of jank and to connect with you guys. Johnny, the topic today is type hints and casting. And so we added the ability to cast this first function here. So we added the ability to take a type erased object and then to cast it to a typed object, and that'll throw if it fails, and which is very similar to the cast function in Clojure. And then we're taking that functionality and we are applying it now to metadata hints, type hints. And so basically this function right here on line 7 and 8 ends up being the same as the function here on line 1, 2, 3. It's just a shorthand version of it. And so then we did a pretty deep dive on the differences between the way that jank type hints will work compared to Clojure JVM. The main difference being that in jank, the type that you specify after the caret needs to be an actual valid type. In Clojure JVM, you can put whatever you want, and it will not be a problem. And then the second thing is that the type that you specify for the type hint needs to actually be the type of the value that you're type hinting. Similarly, in Clojure, in Clojure JVM anyway, you can specify a type hint that is a valid type, but is not actually the type of the value, and that will also just work fine. But in jank, it needs to be valid type, and it needs to be the actual type. And if it's not, then an exception is going to be thrown. So basically, when you combine these together and you think about it in terms of jank, what this means is that when you specify a type hint, you're entering static typing mode, in the sense that like there's a bridge, where you're going from this type erased parameter into the fully typed value that you've hinted, and so jank will insert that bridge, but then like everything after that bridge is just going to be statically typed. We know then that M for the entirety of this entire function, or the entirety, saying entirety and entire is redundant, but for the entirety of this entire whole and everything function and everything within it, the entire thing, we know that it's going to be a persistent array map. And that is a difference. That is a key difference between the way that jank does things and the way that Clojure JVM does things. In my opinion, the jank way is a lot better. But also C++, although we are compiling C++, it still doesn't have dynamic runtime reflection. You can't just be like, okay, well, you're telling me that this is some foo database, and I have no idea what that type is, but maybe at runtime I'm going to be able to use some reflection to see if it's the right type. We don't have anything like that. We don't want anything like that. And so you're not able to type in something unless that type is actually known. In other words, if that doesn't match in Java, maybe just use reflection. If you throw, it's not a big deal. C++ doesn't have dynamic typing. Yeah, I mean, C++ has dynamic typing. Like lots of stuff is dynamically typed in C++. We have runtime type information in C++ as well. That's the way that there's a cast in C++ called dynamic cast, where you can take a pointer to a base type or a reference to a base type, and you can cast it to, you can tentatively cast it to a pointer or a reference to some derived type, and it'll use runtime type information to tell you at runtime whether or not you can do that. So like we do have some of that stuff, but we don't have runtime reflection in the same way that the JVM does. Yeah. The JVM is its own thing, you know, and I'm some parts of the JVM I've had to implement in jank, but this is one part where I don't even like, it's not even that the JVM is doing all this stuff that's going to be tough to do. I just don't even like the way that it works in Clojure JVM. And so I'm also taking this opportunity to, in my opinion, just do it better in jank. Yeah. Sanji, welcome to the stream. Hope you're doing great. And also JTech Visuals. Welcome. I hope you are all having a lovely day. I think it's probably time for another cough drop. So permit my crinkling. Anyways, gotta go. Have a nice stream. Hey, thanks for stopping by, Johnny. Have a good one, man. All right. So what we did was we added an error now so that if the type hint that you specify is not a symbol, then we end up giving an error. This is says it's a persistent list. It's a persistent list because it's a call to quote. And we haven't evaluated it yet. We need to evaluate it. So I think what we'll say is if it's sum, then eval it. Wait, doesn't like building a programming language in C++ take days? I mean, if you want to one-shot it with some AI, maybe you can even do it in less. I think it depends on the language that you're building, and it depends how you're building it. I've been working on this programming language for years. But I'm also building something that nobody's ever built before. Cool. So now we'll check if it's a symbol. If it's not, we'll fail. So that would mean that if we were to do something like, let me actually just yoink this here, and then we'll just do a net, and then we'll just do a type, and then just like a 1 here. That should fail. Yeah, and so this is going to say the type is a small integer. We're not actually able to point at the meta for this, but at least we can point at the parameter. I'm okay with that. You're also a programmer? That's cool. I imagine that most of us here are programmers in some fashion. I think we're done with the parser. Let me leave that open. Oh, hey, Kyle. How's it going, man? I hope you're doing great. Only here a minute. Already called out as a dev. Well, I think not, like, to be fair, not many people are going to click a stream that's about building a programming language in C++, unless they know what those words mean. Yeah. You might have clicked it for the handsome guy. Maybe. I hope that's getting me clicks. I'll take what I can get. Okay, so we'll see if this is a symbol, and we have that working well now. Now we need to actually analyze this as a type. So if it is a symbol, so we can do an auto const type meta sim, and then we'll do an expect object of object symbol on that. So you want to build a programming language like a coding game or a proper language thing. This is a full-on proper language. So we have the compiler, we have the runtime, we have the build system. It's a whole programming language, and the associated tooling. But with that, then hopefully we can build some games. That'd be cool. Speaking of which, and Kyle just joined as well. You know, I don't actually have an easy way to get to Twitter. Oh, and also like I don't even know if I'm gonna need to log in for this. And I searched my own name and I don't even show up. How lame. Who are all these guys? I'm just gonna click one of them. And then change the URL. Got to work on the SEO, man. Yeah, I know, I guess. You guys check this out. So Kyle, who just joined in the chat, made this. And, oh my gosh. Oh, no. Oh, wait, there's an X. Okay. Okay, so I can't click it. Motherfucker. So Kyle made this in jank. So this is using Raylib and Box3D. And this is like a off-roading 4x4 demo. And I think it has adorable aesthetics as well because it's rendered at a much lower frame rate and then just upscaled. The antenna on the 4x4 is an excellent addition of spring physics. Yeah, exactly. Wobbly physics. But anyway, this is a crazy thing. This is written in the programming language that we're building right now. And this was written by one of the people who's in the chat. So shout out Kyle for building stuff in jank. And shout out Jank for being able to build games. Yeah, and Kyle did. He said that he modeled this stuff in Blender as well. So that's made his own assets and then hooked them up with physics using Box 3D. So cool, man. So cool. I should just log into Twitter on there. Maybe I'll have that set up next time. Jank's the next big thing after Epic Games is dropping the ball with UE6. Man, I'll tell you, I hope that UE6 goes well, because I think that the flagship game for UE6 is going to be Rocket League. Rocket League, like the remake. I don't know if they're going to call it Rocket League 2 or whatever. But Rocket League is my favorite game. And it's something I've been playing for a decade at this point. And I would really love for the Rocket League remake that they're making in UE6 to go well. You know, I just really want that to be a great game. So I'm gonna remain optimistic. You know, I'm gonna hope that it goes well, because I want it to go well. But UE6 will be just like UE5, but 50% slower. Man, I hope not. I hope not. Unreal Engine is an amazing game engine, but you can't have a game engine that's been around for 30 years and does so much stuff without it having some big flaws. Okay. All right, we need to analyze type. Let me find where we're doing that. So this is a form. Okay, so we can just do that. Okay. Function context. Huh. Read some crazy shit like dropping the blueprint visual coding language. Yeah, I haven't read anything about UE6, so I don't know. Blueprint is... I'd have to ask my wife what she thinks, if Blueprint's worth it or not, because I haven't worked with it. I know that visual, like node-based stuff, is really popular these days, but I also know that it's pretty limited, and you need to write C++ in order to expose more stuff into Blueprint, and that if you were to just use like Python or something like that, then it may not be a problem. So yeah, I don't know. E33 used a lot. Well, I mean, they know a thing or two. Mad respect for building a language. Not even begin to know where to start for something like that. Well, I mean, neither did I when I started. But it's so I've been I'm doing a conference talk in about 6 weeks, and I've been sort of thinking about the narrative of the talk and what I want to go through. And I've come to the subtitle of the talk, which is basically what was it? I think it was a journey of many small steps. Where the talk is at Nested Firefox Closure Conj 2026. So this is in Charlotte, North Carolina, in the end of September. So about 6 weeks. And we see Adrian Smith here. That's someone in chat as well. This is the speakers, not the actual schedule. Thursday. This is mine. So I've been thinking about this, and I think that the subtitle and overall narrative is basically about a journey of small steps. And on the topic of not even knowing where to start, when I started on Jank, I had also never designed a programming language before. I'd never worked on a compiler before. I'd only worked on like games and game engines and stuff like that. But it's just about putting in the reps, basically, and figuring out all the different pieces and how they come together, and then tackling, like, Jank does stuff that no other language does, particularly, as DJ Blue said, with its C++ interop. And tackling those is just like, well, let's see if we can do this, and then I don't know if it's going to work out, but we're going to try, and we're going to be really stubborn about it and try to make it work and see what we can do. And so far, basically everything I've tried, I've been able to get it to work, which has been pretty nice. Let's see. Okay, so we need the functionality for this analyze type. We need the function context. Do we have a context? We don't even have a functionality yet. Context is created down here. Why do we need a function context for that? Simply because it's passed in to one place for analyze CPP symbol. And analyze CPP symbol doesn't even use it. All right, so I'm just going to pass none. Best of luck. This is a whole other park than where I am around. Yeah, it's I appreciate that. Web dev, game dev, done those as well. Compilers are a really nice break from web dev. The thing about compilers is that you can generally view them as just a pure function. You have your input source, which is immutable. You have some transformation of your input source into whatever different formats you need. And then you have your output, either output source or output IR or output machine code. And so the entire compiler is basically just a pure function. And that's a really helpful way of thinking about it. But also, when you think about it that way, it's like, wow, you mean so like the user is not going to be like completely fucking with my, UI as I'm trying to render something? You mean that like I don't need to handle different UI layouts for mobile and tablets and desktop? Yeah. So you mean I don't need to handle like, because I did a lot of web dev backend stuff. Like I don't need to handle like scaling this and sharding this and provisioning this and it's just data in, data out. Need to handle Windows and Mac OS. Yeah, that is true. Yeah, that is true. But Kyle, I would take that any day. That is, if it's a pick your poison, I will pick that poison over all the other bullshit. Developers and their crazy ideas how to misuse your language. That. You know what? That sounds like a good problem to have. I look forward to that. I'm sure that there will be some unhappy days with people who don't like the language and then write a blog post about how awful it is. But I mean, it's the engine of reality. I'm just happy to be here going through the motions. Okay, so if we get to analyze type, that can fail. So we're gonna need some handling there, and then otherwise, if it doesn't fail, then we just have a type. Now we're gonna need that type to not be a reference. If it's an error, return type X per expect error. I don't know if we need a better error here. We'll see. We might need like an invalid parameter type thing. We'll see. And then, yeah, we need to... I don't think it's going to make sense to have a reference type. I'm not going to worry about that yet, but I'll leave it to do. We need an over-under on the first Rust versus jank. Oh, man. That's such a dumb, like... That's gonna happen. But it's so annoying because jank's not a systems programming language. And so jank is a dialectic closure, right? And obviously Kyle knows this. And so he's very specifically chosen something that would be frustrating. But for those of you who don't know, the jank is a dialect of closure. Closure is a Lisp that is dynamically typed and garbage collected and functional, with persistent immutable data structures and lazy sequences and garbage collection all over the place. It's not a systems programming language. It's not even in the same category as Rust. It doesn't try to be in the same category as Rust. But because jank interops with C++, people will just assume that like it should have C++ performance and not the performance of a dynamically typed garbage collected functional Lisp. And so, yeah, I already get people who are like, you know, I compared Jank's performance to Clojure JVM and like they're about the same, and people are like, oh, I thought C++ was fast. I'm like, oh, you think you're so fucking clever. Because the way that you would actually write C++, if you're just writing C++, would be so different, right? You wouldn't be using a garbage collector. You wouldn't be using dynamic typing. You wouldn't be using persistent immutable data structures. You would just use value types. Hey, Supercube, welcome to the stream. Hope you're doing great. What's Clojure usually used for? I'm not familiar with it. Clojure is really big in enterprise software. The biggest customer of Clojure is Nubank, which is the largest bank in South America. But Clojure is also used a lot in like insurance and a bunch of other stuff. Netflix uses Clojure. They've been using Clojure for over a decade. I think they're doing it on like data science for the like studying. I think it's for studying the like how people use Netflix. I don't actually remember the details. They did a talk on it last year at the Conj. Apple, Walmart Labs, that sort of stuff. Supercube, my company's using Clojure heavily. We use it the same as you would Java. Yeah, I think that's a good way of putting it, Supercube. Thanks for calling that out. So basically, like, Clojure runs on the JVM by default. And so anywhere you would use Java is a good place that you would probably be using Clojure. Stable, reliable, exactly. That was the big thing with Netflix's talk last year at the Conj, was they're like, yeah, we've been using Clojure for a decade, and we've been using it for this particular stuff, and it's scaled, really well. And then a decade ago, we also were using all of these technologies, and then they kind of went through like year by year and talked about all of the breakages that happened with the other technologies that they were using. And meanwhile, they just kept using Clojure, and Clojure was still stable, and Clojure still performed, and did everything that they needed it to do. And then 10 years later, when they compare the technology stacks side by side, like the only common technology between the two in the stack was Clojure. That was basically the gist of what they were saying. Yeah, I know what you mean. Although don't ever compare Clojure to PHP in front of other people, because PHP it's triggering. Be careful with that one. Okay, so if we have a type now, I'm running like one code per 10 minutes, but we're getting there. I think that's it. So I think if we just say So we can say, no, I want to keep that. And I can just say param type is equal to type expr expect okay. There are PHP closure tags. Yeah, actually, so that's the other big point about Clojure is that although it by default is on the JVM, Clojure is a really unique language in that it's actually has a whole bunch of different dialects that are on different hosts, and so there's Clojure on JavaScript called ClojureScript. There's Clojure on CLR called Clojure CLR. Then there's Clojure on Go, and there's Clojure on Python. There's Clojure on C++, which is what we're building, and they're all still considered Clojure, but they run on these different things, and they interop with their host in different ways. Okay, so when we place a local here, we have a local binding. And a local binding should have a type. It does. Current frame. That's kind of annoying. So we're going to need to look this up again and then grab the back. And then from there, we can do the type is equal to param type. Okay. So this allows us to get the type. And we save that here. The only thing is that we don't have this information inside of the function itself. Because the function arity here just stores the param symbols. Okay, so we do put the symbol in here, and we do have the meta still on the symbol, but we'd have to pull it back out. We'd have to pull it back out and analyze the type again during code gen if we want to do that. Or we store the type separately. Where's the module? There we go. So we have a pointer to the function arity here. And the arity is what we're building up here. I think maybe what we should do is we should just add this info to the arity. Probably right here. So we end up moving in the param symbols here. So we should just redefine param symbols here to be or not to be x per parameter. And then param, and so we're going to need a param.name. Param.name parameters. And so we're going to in place the param type like so. That's going to break in some other places, but that's okay. That's going to happen. So now we're going to have the name and the type of the parameters. That's actually going to be stored in the AST. Hope I'm not stepping on feet again, but giant 2,000 plus lines of code file doing all this processing. Yeah, this is the largest file I think in the code base. It's almost 6,000 lines, and it is too big. But I also don't yet know how I want to break it up. So for now it's growing. Yeah, the parser is a couple thousand lines. I think overall jank is about 50,000 lines, something like that. All the C++ code, which is not that much when you compare like other C++ projects, like what you can do in 50,000 lines. But it's a chunk. And yeah, like yeah, no, I get what you mean. I don't like having the files this big either. But at some point it becomes a practicality thing as well. Hey, next tab. Thanks for the raid of 25. That's great. Welcome to the stream, everyone. I hope you had a great stream, next tab. We're working on the jank programming language, which is a native dialect of Clojure. That's on C++. We have seamless C++ interop, which is something that you've probably never seen before because it's kind of fucking bonkers. But also next tab, I know I'm always exhausted at the end of my streams. If you need to raid and run, then by all means, do what you got to do. But yeah, this is a glimpse of what jank looks like. So it's a Clojure dialect, which is a Lisp, but you can also just seamlessly interop with C++. And so this is just straight up including a C++ header file, grabbing an overloaded C++ function, renaming it, and then later calling that, getting overload resolution, everything like that. So anything that you would want to do in C++, including RAII and exceptions and template instantiations and everything you can do inside of jank. But also on top of that, it's a dynamically typed garbage collected Lisp that has REPL-driven development and all of the other Lisp goodies. And so it's kind of this very odd combination of the two of them together. Let me make sure I drop a follow on the next tab. There we go. But no matter how long I code, I never have to be perfect. I never have the perfect feeling how to split it up. It's too finicky. Yes. That's, I think, Yeah. I mean, I'll be the first to say I don't like how big this, I don't like how big the file is. But there's actually a cost to splitting it out, right? And so the way that C++ works is, at the top of each file, you have all these includes, right? And we got a fuck ton of includes for this particular file because this file's touching. So this is the whole analyzer. Outside of some util files, this is the entire analyzer for the entire language. It's a lot, right? But if I were to split this out into different files, then I would have multiple files now, or as we call them in C++, these would be translation units. I would have multiple of these files that are including some of the same bits, right? Because they all need to access the same stuff. And then I'll need to compile both of those translation units. And I'm actually going to end up slowing down the compilation time of the compiler because now I need to do extra redundant work because I wanted to break these out into different files rather than just having one larger file. So the organization, if I were to break this out, is literally gonna cost in terms of compile time, and as you know, like as I iterate on jank, I want compile times to be as small as possible, and so like that's conflicting. But also, like I think I will end up breaking it up. I just want to be sure. That I'm clear on like how it's broken up, because if I just break it up into a whole bunch of pieces, then I'm gonna add another like 30 seconds to the compile time of jank. If I just pull out some bits, then you know maybe it's gonna help, but it's not gonna be as logically easy to follow. And so sometimes I'll just leave things as they are until it's clear that a pattern emerges, and as DJ Blue said earlier, some good designs take time, right? And when you see those patterns, and you're like, oh, okay, I see. So we don't actually have 2 things here or 6 things here. We have 3 things here, you know, and like, let me separate these 3 things. How long is the compile time right now? I think debug builds are clean builds, probably 5 minutes. That includes compiling all the C++ code into a phase 1 compiler, and then using that phase 1 compiler to then compile a whole bunch of jank code, which then gets compiled back into the compiler for the final phase 2. But yeah, about 5 minutes. Hey, Easy Light, welcome. Hope you're doing great. Okay, so let me save this and then deal with whatever havoc we just caused. Hey, Kaylee. Now that's a fun name. Kaylee Kameoka. Or is it Kameoka? Kameoka. Kind of sounds Japanese. Kylie Kameoka. Welcome to the stream. Hope you're doing great. Kylie Kameoka's right. Nice. Expert function 35. So yeah, so like I just changed the shape of some stuff here, and I need to fix name. Wait. Name. And then IR processor 223. There's going to be a bunch of places. 242. Also right here. Also right here. Also right here. So do you have like a test program that needs to be compiled by the newly created compiler, which has every conceivable function call in it? If you want me to just shut up, just say so. This is just so far removed. Yeah. No, I no. There's no no need to shut up. I'm here to work and hang out with you guys. So yeah, Jank has 3 different test suites. Testing is incredibly important. And so we have a test suite. We have a unit testing suite, which is the smallest of them all, because unit testing is the least useful. Then we have a regression testing suite, which is a set of 825, I think is what we're at now, different Jank files. And those are the ones that just exhaust like all of the different permutations of semantics, to verify that everything works fine. And then we have an end-to-end testing suite as well, and that one actually tests kind of how everything comes together using the Jank binary and the tooling and kind of plugging it together in the same way that the user would. And all of those tests run continuously in CI. Here for the co-work vibes. Oh, cool. Working on UI design system. Also write code. Just haven't done C++ a long time. Nice. Happy to co-work alongside you. Hope you get some good work done. I'd say we've been reasonably productive. Let's see. Evaluate. I was 165. Params, wrap expression, params. When do we use that params arc? Right now, everyone's just passing an empty map. Yeah, it's literally never used. Yeah, maybe it's used somewhere else, but not here. I am gonna try removing it. All right, we'll see if that broke anything else. Could be that there was a different transition unit that was using that overload. Or using that parameter anyway. No, this one's not using it either. $164. Yeah, we need a name here. Doing all right. Nice. Okay, so with that done, we should just be able to add code gen now. I'm going to go refill my water and use the restroom, and then I'll be right back. So now the only thing that we need to do is we need to use this type information in yeah. Oh, we need to ensure that the type is actually trait convertible. That's fine. Let me note that down. Yeah, this one's going to need a set of tests. Where are we? Right here. Yeah. Okay, but ours is right now, and so we don't need to worry about that. That's not right. So let's fix our IR because the parameter type here should not be object ref. The parameter type, I think we're just hard coding that right now. IR processor, so parameter. Yeah, we're not specifying the type for parameters right now. Yeah, so we need to add an overload to parameter here. No, we don't need another overload. We can just add a parameter because we're always going to have that type now. We're like always explicitly typing the parameters rather than just assuming. And then we can remove that hard-coded type. We just had a hard-coded type of untyped object ref. Just remove that guy, and then the rest of this is already going to work fine because it's already just named the same thing. It's almost like I did that intentionally. And then we just need to specify the type here, and we have that because that is param type. There we go. So let's have that build, and then we'll take a look at the updated IR. We should see the too few. Oh yes, because here when we're constructing the parameter untyped object ref. Analyze. So there's always an implicit parameter for basically the this object, and that's still untyped. All right, let's look at our IR. Cool. So now we see that parameter is actually a persistent array map ref. So our type information has made it into this IR now, which is great, which is super great. Nice. Now the only thing that we need to do is we need to handle the parameter okay, so here's where we're adding all of our params. And This is for the C++ code generation. You can see here that we're just looping through params, and then we're just assuming that they are all this object ref, and then we're just grabbing the name. We're not going to assume that anymore. Oh, no, we are still going to assume that, because we're going to start as object ref. Yes. Okay. Now we need to deal with the trait conversion. Now, the difficult thing here is that we're still treating the parameter with the same name. And so the parameter here has the name m. But what's really going to happen is that we have some parameter that's an object ref. It's behind the scenes. And then we're going to do our cast. And then that casted value is going to be called m. So we need to have some like hidden parameter, or we need to do some shadowing. Let's see which one is going to make sense. Let me finish my protein bar. That's probably one bite. Yeah. So we can't just define a local with the same name. Even if we try to shadow it, because they'd be called the same thing, C++ is not going to be smart enough to look in the previous scope. It's going to assume that it's appearing in its own initializer. So what this means is we need to rename the parameter. And we do this, would it be bad to emit two functions, one object ref? Well, and then you you couldn't, though. You couldn't directly dispatch to the map one because it's not going to be part of the callable interface of the object. The call on the map ref is going to go through the call facade on object ref, and it's not just going to forward arbitrary things through. So you can't do that. And also, it would increase the size of the object because we need to keep track of, like, we don't actually generate a struct. We instead generate, like, you might think that we, like, generate a class or a struct that has member functions for all the call functions, but we don't. Instead, we generate each of the call functions individually as its own standalone function. And then we have an object that just holds a bunch of pointers to those functions for each of the different arities. And so we have like 10 different function pointers for all of the 10 different arities that we support. And so if we wanted to support also arbitrary other arities with different types, then that's going to grow the size of that object even more to store those. And then anyway, it just won't work. But that also means that, like, because of the way that we do it, we can't actually rely on overload resolution to just help us out there because we have the indirection. And we used to generate structs like that to where that could have worked, but Clang really doesn't like when you generate that many structs in terms of JIT compilation, because when you compile something like Clojure Core, you're compiling several hundred different functions. The Clang JIT runtime really struggled with that. And so this way of just generating a bunch of standalone functions and then getting pointers to those functions was significantly faster to JIT compile. So it's what we do. But good thinking anyway. Instead, what we're going to do is we're going to rename the parameter to something else. If the parameter type is not an object ref. And then one of the first things that we're going to do once we're in the function, which is in the function right here, is then we're going to introduce the parameter under its supposed name, but with the new type. And then we'll do our trait conversion for that. I'm just thinking about how we want to name these parameters. Probably better to just do a map of parameter names. We don't need a map, actually. Just use vector. So we'll say if the param type is untyped object, then yeah, go ahead and do this. And param names, place back. Are we going to need param names? Yeah. All right. don't want to munge this twice, so we'll just do munged. And then I don't have this. Got a sneeze coming along. Analyze. That should fix that. Good. So if it's not an untyped object, then we're going to do the similar sort of thing, except we're going to grab the type here, and we're going to say get qualified type name on param.type. And oh, cool. We don't actually need that, so that means we should just be able to do that. And then the name, we should just come up with something. Yeah, we should just do basically a gen sim here. So that's going to give us a unique name for the parameter. We're going to store that here. And yeah, then we're going to need to loop through, once we start the function body, we're going to need to loop through the params again. And we'll say, okay, so if this param is not your normal untyped object, then now we need to actually introduce our new untyped object. So we'll do a jank runtime convert on the type from object, and then this is going to be our parameter, and then close that. And so we have our param name, and we need to munge this guy, just as we were doing up here, param name, arrow name, munge. So we'll do munged there. And now we need the type. And so the type is going to be the same type. So that's just going to be get qualified type name of param type. And then from object, that's going to be our param names. Oh, we need an index here. I think that's it. There we go. Permit me while I floss my protein bar out of my teeth. No, I don't want to save this. Did I not say that? Okay, good. And then run. Nice. And so now, check it, we're done. So we have our parameter type. Wait, no, this is wrong. We're not done. Yeah, because we need to. No, this is not the same. This needs to always be object ref. Why did that work, you're wondering? Because it's undefined behavior. We casted this function to be a pointer to a function that takes two object refs, even though it doesn't take two object refs. Okay, now we try. Cool. Now it takes two object refs. This guy is just called G__3. That's the gen sim. And then here is where we introduce M. We take this guy, we convert that to a persistent array map. And then we call get on M. So let me double check. Get. All right, so we don't actually have any overloads for get that that work on like fully typed things, but we could, you know, we could have a we could have a template in there. Can we prefix the gen sim with the original name? Okay, now things get fun, because now we get to see what happens if we try to do this with an unbox type. And what do we want to do here? Nice. So now you can also add a type hint and say, I'm expecting this to be something that works with a trait conversion. And then when we do our analysis, so let me just verify here. If I do foo, this should end up telling me there's no foo member in an int. Yes. Yeah. So when you add a type hint here, and again, this is how it's going to work in jank compared to Clojure, we are going to in the analyzer, we're going to assume that for the rest of that function, that is the type of that value. And so all of the overload resolutions that we do, the member access, everything like that, is going to be based on that value. And we'll insert that bridge to take you from the object ref into that value. But once you're there, everything is golden. Standard string, sure, we can put that here. Foo. So this is going to, I don't know what you wanted to test with this specifically. Did you want to test the failure case like this? There's no foo within standard string. Or did you want like here we could return this. This is gonna unbox it like so, and then it's gonna box it back up again for us before it returns. And then I think that we're gonna probably want ref on that guy. So yeah, we need to lock this down a bit. We need to make sure that the types that are provided are actually trait convertible, and we need to make sure you don't put like a ref or something like that because it's just not going to make sense. But yeah, so yeah, it works with any native type that is has convert T support. Yes, exactly. So it's going to work with anything that's trait convertible, which means you can provide your own trait conversions, and then you'll be able to use type hints for that type if you want as well. The downside of that is, of course, that trait conversions are, they're effectively marshalling. You got to pay the cost in order to convert to and from. For complex stuff, for strings, like if you're just going to pull out like the underlying JTL immutable string, then there's no actual copy that happens there. So if you didn't want a standard string there, if you just wanted a JTL immutable string, right, then there's no copy that happens here. We're just gonna give you the underlying string, and that's gonna be great. Similarly, if you want to pull out like an integer. So I mean, go, back to what I had here. If you're pulling out an int, then, there's no dynamic allocation or anything that needs to happen. We're just gonna, if you have an integer ref or a small integer ref, then we're just gonna pull the value out of it and return that. Nice. So what I really like about this is it effectively achieves Clojure's semantics for the way that type hints should work. It supports any type that is trait convertible, and it hooks into the analyzer from the very start such that the entire function is effectively analyzed as though it's statically typed, right? We're going to analyze that entire function knowing that I is an integer and nothing else other than an integer. And that's a big difference compared to the way that Clojure JVM does this. How this work with a CPP on box? It won't. I mean, the CPP on box is for opaque boxes. And so you could type hint your object as a jank runtime object opaque box ref, but you'll still need to do a CPP on box on it. Oh, hey, Joseph. How's it going, man? So the other thing, DJ Blue, is the types here still need to be trait convertible. And the So this means that we're not just, we're still not operating in terms of like, here's a function that actually just takes an integer, right? For that, you're going to need the CPP defen or CPP fun to just write a function that takes an integer. Is there a TLDR for what you just talked about? Definitely interested in boxing unboxing. Yeah, I'll give you a TLDR, Joseph. Okay, so what we've done on stream today is we already had this cast operation, CPP cast. We made it so that it now supports casting from a type erased object to a fully typed object. And if the type erased object, like this O, is not actually a persistent array map, then it will throw. And if it is a persistent array map, then great, you get back a persistent array map, and then you're able to use that. So that laid down the functionality for us to then add type hints. Now, our type hints work differently from the way that Clojure JVMs work in two ways. One, the type that you specify after the type hint, after the caret, needs to be an actual valid type. In Clojure JVM, that's not the case. And then two, the type that you specify needs to actually be the type of the value that you pass in as well. And if it's not the correct type for the value that you pass in, you'll get an exception. So with those two differences, what we've implemented is the ability to type hint right now just function parameters, but it allows you to say the type that you expect your function parameters to be. Now, the function parameters will still be untyped objects. The only difference is that we end up generating some code that at the start of the function is then basically going to do the CPP cast to try to convert whatever the untyped object is that the parameter is into the type that you type hinted. Now, an extension of the way that our conversions work is that this also works for non-jank object types. And so if you wanted to do this with int or char or long or something like that, it works for things that we support trait conversion for, which is a specific jank method that we have for converting to and from native types and jank objects. So as long as there is a registered conversion trait in jank, you're going to be able to specify, you're going to be able to type in your values as that type as well. And then the final cool thing is this is hooked into our analyzer from the very start. And so when you type in something as an int, you're saying to the compiler, like, this is going to be an int. It has to be an int. And that means that for the rest of the entire function, the analyzer is going to treat it as an int. And so any sort of overload resolution you do or anything like that, it's gonna work exactly as an int would. And we're basically entering static typing land at that point. Jank is just gonna, when it does code gen, it's just gonna put in a little bridge that's gonna go from the object ref, which is the type erased object, into the int via the conversion trait. So the last thing I was telling DJ Blue when you came in is this is not the same yet as actually just defining a function that takes an int or defining a function that takes a standard string or something like that. For that, we'll have a separate mechanism, which is the CPP fun and CPP defen. And so for those, you're actually just going to be able to say, like, okay, this, and then let's say we want to take a ref to const standard string and then name, and then this is actually, you'd have to specify a return type here. So let's say void as well. So this is actually a C++ function that returns void and takes a standard string, a ref to const standard string called name, right? We don't support this yet, but we are going to support this. And so there's no trait conversion, there's no boxing, there's nothing going on here aside from just a straight up C++ function. Now, the really cool thing about these C++ functions, once we support them, is just like in our closure functions, you can just call right into C++. Inside of the C++ functions, you're going to be able to just call right into closure as well. And so here, if you wanted to just do like a print line of name, that's also just going to work fine, because it all compiles down to the same shit. Now, of course, the C++ functions are like, you're not going to be able to pass a C++ function like hi here into something that's expecting like closure objects. So if you wanted to do like a map hi over Joe and Sally, then that's not gonna work. Maybe we're gonna be able to come up with some sort of function adapter to make something like that work, but I don't know, we'll have to see. But to start with, the whole point is that like the C++ side of stuff is you're specifically opting into that because you want the performance. So yeah, we're going to be able to have CPP struct. So you're going to be able to do something like, I don't like that indentation. It's probably going to be something like this. And then this would be like a standard string name, something like that. So I think that with CPP struct and CPP def and CPP fun, we should be able to basically write effectively C++ code, but it's going to be through jank syntax. And if needed, the performance of that is going to be so drastically different compared to the closure-y C++ that it's just going to blow like the JVM out of the water. So if you're ever going to need to drop to C++, you probably don't even need to leave the jank syntax. You can just write it in jank syntax using CPP struct, CPP defin. But those aren't done yet. And so it's important not to confuse this with that. This is still a closure function, right? This is still a function that takes a type erased boxed object. The only difference is this type in is specifically saying, and then, before I can use this object at all, I want to make sure that you try to cast it to this thing, which will throw if it's not actually convertible. These can be mixed and matched in the same file. Yes, absolutely. They can be mixed and matched in the same file. CPP defs and CPP defins and these normal defins and the type hints and all of it goes in the same file. And all of it can be JIT compiled as well. Yup. Does that answer all the questions that you had, DJ Blue? Limits to how many primitive types can be type hinted, like in JVM? No. I mean, we need to have a trait conversion for it, but we already have trait conversions for every integral type and every floating point type, as well as a bunch of other stuff like standard string and even more complex stuff like standard vector of anything that's trait convertible using concepts. So then you can do a lot more. Just tune back in. Will the type pins support only trait conversions or also checked CPP unboxing? Yeah. So DJ Blue was asking that as well, Kyle. I think we're probably just going to do trait conversions, as well as like this, this sort of case where you're going from an object ref to a persistent array map ref. I guess we can call that a trait conversion, because there is a trait for it, that just does a try object and throws an exception if it's not of this type. I think with opaque boxes, you have an ambiguity, right? Is it an opaque box that holds something, or is it a trait conversion for the type that you're specifying? Because it's possible that you would have something in an opaque box that's also trait convertible. I think if we could find a good unambiguous way to say, like, I'm expecting an opaque box that holds this thing, then we could consider having that as a type hint. I don't see it right now, and I don't want to just jam it in. So yeah, this won't help in that case. This will help. So the opaque box case is mainly for code cleanliness, right? Where you're just like, yeah, I got this boxed pointer to this native handle that I'm passing around a lot, and I don't want to have to unbox it all the time. Whereas the type hinting that we've done here is almost entirely for performance, which is like, I'm expecting this thing to be this type, so now analyze the rest of the function as though it's that type, which is then going to ideally change your overload resolution and everything like that to be based on the type that you're saying that you're expecting this to be. Yeah. So, Kyle, I think that I was just talking about the CPP defin and CPP struct and stuff. I think that one way out of the box unbox hell is, once we support CPP defin anyway, is to use a CPP defin that takes an actual like raw pointer or reference to the thing, and then just put your work in there. But the drawback is that CPP defins, at least to start with, are not going to be redefinable. There is some LLVM work that's happening for like trampoline functions to make it so you can redefine functions. But it's messy. So we might get to a point where that's viable, especially if the signature stays the same, but the body changes. And then I think we can make that happen. But currently, I don't have a good solution to clean up the unboxing in normal closure functions. And I'm open to suggestions. Yeah. We... Because you could imagine doing something like you can imagine doing something like this, where you're like CPP unbox here. Oh, we don't do that anymore. This is a little better, probably, than having to do it in a let. But it's still pretty verbose. Syntax sure can always come later. Yeah, I agree. I think we'll see, but I recognize that that unboxing is annoying, and I want to improve it. Just want to find a good way to do it. Also, Kyle, one of the things that we talked about before you showed up was not using the tag keyword, but instead using a different keyword. And so right now, when I implemented this today, I used the type keyword instead of tag. My reasoning was that since jank requires that the type that you specify as the value of that keyword, whatever the keyword is, since jank requires that that is actually a valid type, if we were to also use tag the way that Clojure uses tag, then we are specifically opting jank into breaking wherever like someone is adding tag metadata to something, like in a macro or whatever, that's using JVM types. So I was like trying to ignore the tag keyword, so that way we're less likely to break on any JVM types that are in tag keywords, which is hopefully going to make jank more portable, but at the cost of using a different keyword for the type. I don't know if that's... I left it to do because I don't know if that's still like, if that's a great move or not. I can see arguments one way or another, but it's already going to be a pain in the ass if you try to run something with type hints in jank. Yes, for that exact reason, Kyle, is that if you have any sort of type hint for a Java type, that's already going to break jank. But that one's unavoidable. The metadata one, where someone's just adding the tag meta on something, it is avoidable if we just use a different type, keyword for the tag. If we use a type keyword or jank / tag or whatever, we use some other keyword, then that problem is unavoidable. Is avoidable. The one where it's actually just a caret and then some symbol, that one is unavoidable. It's just going to break jank. Reader conditional type hints. Yeah, I think does the reader should support that. If you did reader conditional CLJ and then string and then M and then this. Apparently not. So you'd have to do this. But that's still viable. Like you could do, you could do this. Yes. Yeah, it's super ugly. And this is why some of the vibe-coded Clojure dialects recently have been showing off that they have Java support, and they're basically faking that they support all these different Java types, and not only types but also like actual functionality. So like, oh yeah, you can use line reader and all like the string functions and everything like that, and they've backed those interfaces, with their own platform specific implementations of it. But it allows them to run, all of these different Clojure JVM libraries that are actually doing Java interop. Alex Miller spoke up about that recently and said he did not think it was a good idea. And I also don't think it's a good idea. But I see the appeal because there's all this code that's written with Java interop, and you kind of want to, meet that code and those developers where they are, without saying, actually, all those type hints you have, you should wrap in reader conditionals. Yeah, it was also surprising to me, Kyle, that you could put invalid types there. We were doing some exploration here before. So jank or Clojure allows you to, one, specify a completely bonkers made up type there. And then two, Clojure allows you to specify a type that is not actually the type that the value even has. And neither one is an error. And so it's just like you have these two sort of silent failure modes that I think are both an awful UX, because the whole point, like if I add a type hint, it's a very intentional thing that I need to do in order to go into some code and say like, I want a type hint here, right? If I fuck that up, I want it to tell me. I want that to be a problem, because I'm not going to add a type hint unless I specifically want to convey to the compiler like that something is of a particular type, generally for performance. And if I got that type wrong, I should know. I don't like the way that Clojure handles that at all. But jank's not doing any of that. So like we have the same syntax, but really very different semantics for the way that the type hints work. And in my opinion, the semantics are a lot better. Yeah. Anyway, so we'll see. We'll see about the opaque boxes. I don't know. I hope that there's something we can do to clean that up. And that in the future, when we have that, we'll look back and it will be obvious. and we'll all feel very silly. But right now, I don't know what it's going to be. I don't know. But I think I'm going to wrap up for today. I made it longer than I thought I would, being sick today. But my throat hurts and I'm tired. But we implemented the CPP cast functionality for casting from type erased objects into typed objects, and that's lovely. And we also, to my surprise, actually implemented all these type-ins, and I'm super pleased with that. So I'll clean all that up, and I'll add tests, and I'll add it into the other places where it needs to be, and then we'll get that merged. Thanks all for hanging out. It was a good stream. I enjoyed it. I hope you guys did too. Until next week, adios.